All right, hi guys, very good evening everyone. Welcome to Om Institute and welcome to this session once again on the GATE PYQs. Yes, okay, some time back I took the session on control systems. 1 mark question separate, 2 mark question separate, complete 5 years ECE and EE, all questions combined, every single question was discussed. Okay, and as per the students' request, okay, when I was taking control system, students requested to also bring up the similar session for signal and system, and yes, that is what we are going to do. This session, this particular video, we are going to talk about the questions of signals and systems. As you can see, 1 mark questions today. Okay, all questions from 2021 to 25, 5 years straight, ECE combined, all questions of ECE and EE, none of them skipped. Okay, and then next session we'll discuss all 2 marks questions. Okay, before we go into it, you should be ready for this particular 1 mark question practice session. All right, very good evening everyone. Come on, let's get started finally. Okay. And none of them skipped. Okay, and then okay, fine. Okay, yeah, so let's get moving ahead. Let's get started. What is there in this particular session? What are the questions in this particular session? Okay, number 1. So there is a system, okay, with input xt and output yt given by x e power t. GATE 2023 ECE 1 mark question it is. Whether the system is, you have to comment on causal and time varying nature of the system. Okay, so now, very simple way to comment on this, if you have followed, any of my classes earlier I have taken. Okay, see here, yt is x e power t. There is a separate function of time. Okay, changes in the time argument, either a separate function of time or changes in the time argument. Okay, changes in time argument. Like if it was x of t, okay, the time argument is t, but the time argument is made as a function of t. Changes in time argument always will make the system time varying. Always will make the system time varying. And you have to solve it that way. You should know this technique. It's a 1 mark question. Okay, so that means what I mean is any time if you are given yt as, x of t, okay, then okay, it could be time invariant, but here I am talking about x of f of t. This is what I mean by changes in time argument. Anytime you see anything of this kind, it is going to be time varying. Anything of this kind, that is time varying. Next, causal or non-causal. Okay, causal or non-causal. One simple value. Okay, what is y0 is x e power 0, but what is e power 0 is 1. That means to calculate the output, okay, at t equal to 0, I need the value of the input at t equal to 1, okay, which is future, right? And hence the system is non-causal. Future values are involved. Okay, so what is the answer? Non-causal and as well as time varying. Non-causal as well as time varying. This is what is the answer. All right. Yes. Hi. Good evening, Nitesh. Good evening, Ashrita. Okay, in the Telegram group only. I will reshare it. If it is not found there, I'll reshare it, Ashrita. Okay. Okay, guys. Next question. If the input xt and output yt of a system are related as yt equal to max of 0, xt. Okay, then the system is what? GATE 21 EE 1 mark question. This one is GATE 21 EE 1 mark question. Okay, then the system is what? Okay, now let's solve this particular question. Okay, linear and again, so here linear and time invariance. These are the two things to be checked. Now, yt is max of 0, xt. Yt, can I write yt like this? Yt is maximum of 0 or xt. That means if xt is any positive value, okay, xt is any positive value, okay, the answer will be xt, because positive value is greater than 0, we have to consider the maximum of them. But if xt is any negative value, then who will be maximum? 0, then the answer will be 0. Then the answer will be 0, or you can even write it this way: yt is equal to x of t, okay, u of x of t. Understand this notation now, because if xt positive, now see how does unit step function works. Okay, we all know about unit step. If it was ut, what will you say, dear? Okay, for t greater than 0, okay, for t greater than 0 ut is 1, for t less than 0 ut is 0. That is what you will say. Okay, so if here I have put u of xt, if xt greater than 0, answer of unit step will be 1, xt into 1, xt. But if xt is negative, unit step answer will be 0. Okay, overall answer will be 0. xt into 0 will be 0. That's what I actually want now. Okay, right. So now definitely it cannot be linear, because linear means yt as a x power 1 function, not u of x function. Or otherwise, one more simple way I will comment on linearity. Now, time invariance. What are the factors responsible for making the system time variant? One, I told you, changes in the time argument. Okay, changes in the time argument. One more thing, if you see like this, okay, any separate function of time, suppose yt is ft multiplied by xt, separate function of time. Either changes in the time argument inside or any separate function of time multiplied. This also will always be time varying. But here, there is no separate function of time. There is no change in the time argument. Inside the bracket, t is t only. So this is definitely going to be time invariant. Time invariant. Okay. But because of u of x function, it is non-linear. I will explain you non-linearity by one more thing. Because you should know linear, okay, means the relation between input. If you draw y versus x graph, it should be a straight line passing through origin. That too passing through origin. That is what linearity is defined as. Okay, so definitely it's for straight line passing through origin, the only relation allowed is y equal to x, y equal to kx at max. Okay, now take one more example. Okay, if this is non-linear, why? Suppose if you take a input x1 equal to 3, what is the output y1? Okay, now if the input is 3, okay, 0 or 3, which is maximum? 3. Answer is 3. Okay, if you take another input xt as -1, what will be the output y2? Okay, now if this is -1, 0 or -1, who is greater? 0 is greater, output will be 0. Output will be 0. But if I add these two, if I take the input as 3 plus -1, which is 2, okay, what will be the output now? Okay, now out of 0 or 2, who is maximum? 2 is maximum, output is 2. Does this output equal to y1 plus y2? See, I have added the input x1 plus x2. If it was linear, it should follow additivity, and additivity says that if two inputs are added, their output should also be added. y1 plus y2 should be 3 plus 0. 3. It is not equal to 3, and hence non-additive, non-linear. Non-additive means non-linear. Okay, so it is non-linear but time invariant. It is non-linear but time invariant. Good evening, Inspire. It is non-linear but time invariant. Okay. Okay. Next question. Non-linear and time invariant. This is what it is. Okay. Okay. Then I have the next question ready. Consider a continuous time signal xt equal to minus of t square u of t plus 4 minus u of t minus 4, where ut is the continuous time unit step function. Let delta t be the continuous time unit impulse function. What is the value of integral minus infinite to infinite xt delta t plus 3 dt? Xt delta t plus 3 dt. Simple question. Now see, integral minus infinite to infinite xt delta t plus 3 is nothing but x of minus 3 as per the integration property of impulse. Integral xt delta t minus t naught is x of t naught. Okay, so this has to be x of minus 3. The value of the signal xt at minus 3. Now, what is this xt minus t square? Ut plus 4 minus ut minus 4. Now, if you only think about this part, okay, ut plus 4 minus ut minus 4. Okay, subtraction of step signals, okay, will be a rectangle. Ut plus 4, okay, it starts from minus 4. Ut minus 4 at 4, okay, and there will be a rectangle from minus 4 to 4. Subtraction of two unit step signals of equal amplitude will give you a rectangle. So this rectangle will be from minus 4 to plus 4, right? Minus 4 to plus 4. Okay. Simple logic. Now from minus 4 only one unit step is starting. From t equal to 4 another is also starting. So both will subtract again. Na? 1 minus 1 0. So again result is 0. So that is why what is the net? Net is a rectangular pulse from the first point to from the starting of the first step to the beginning of the next step. Okay. In between that you get the 1. Okay. Okay. So what is x of minus 3? So now at t equal to minus 3. Okay. The value of this part, rectangular part is 1. So answer is going to be minus of t square. What is t? Minus 3. Okay, into this part which is anyways 1. So answer is minus of 9. Answer is minus of 9. Option number A, gate 25, current year EE 1 mark question it is. Okay, yes, Ricky, Sai Vikas, Vasudha, correct answer. It is A. Simple one. It is going to be A. Okay. Next question. Okay. Another gate 25 EE 1 mark simple question it is. A continuous time periodic signal is given to you 1 plus 2 cos 2 pi t, 2 cos 4 pi t, 2 cos 6 pi t. Okay. If t is the period of xt, then 1 upon t integral 0 to t modulus xt square dt. Okay. What is this expression actually equal to? 1 upon t, okay, energy in one time period, okay, 1 upon t into integral mod xt square is the energy formula. How much energy? 0 to t, that is energy in one time period. And this is the expression actually required to calculate the average power in the signal. Average power, time average power in the signal, right? Now, how do you calculate the time average power, or what is the time average power for any sinusoid a cos omega t? It is a square by 2, it only depends on amplitude. A square by 2, RMS value a by root 2, average power is a square by 2, right? And when sinusoids of different frequencies are added, the power is additive in nature. Okay, for the constant term like 1 or C naught, the power will be simply C naught square. So what is the total average power here? For 1 it is going to be 1 square, for 2 it is going to be 2, for the next term it is 2 square by 2, a cos omega t, a square by 2. Again the next amplitude 2 square by 2, then the 2 square by 2. Okay, so 2 square by 2 is 2 only, so 2, 2, 2 and 1, total answer 7. Simple question, gate 25 EE 1. Yes, Ricky, correct answer. It is 7. It is 7. Okay, this is one way, or you can even, say the answer with the help of Parseval's theorem. As per Parseval's theorem, now you can also assume that this is the Fourier series expression for a signal having the frequency omega naught. I mean, there is one more way. You can call this as omega naught. So this is twice of omega naught. This is thrice of omega naught. And then this is 0 frequency. This will be 0. This is the constant of DC. So you have DC and omega naught, 2 omega naught, 3 omega naught up to third harmonic. Okay. So as per, if you apply Parseval's logic, as per the Parseval's power theorem, the average power is nothing but summation of minus infinite to infinite mod Ck whole square. Okay, so even if you solve it by that logic, okay, what is the Fourier series coefficient? 1, then 2, then 2, then 2. Okay, 1, then 2, then 2, then 2. Okay, so that also you can do. No, not 2. You will have to first 2, e power j, because I am writing Ck. Ck means exponential Fourier series coefficient. Okay, so it will not be 2. When you break this cos omega naught t e power j theta plus e power minus j theta by 2. So this 2 and 2 will get cancelled. Okay, that you will take it. This 2 and 2 is going to get cancelled. So, that ways you can solve it. So this is one alternate that, I have presented in front of you. Okay, if you want, you can take the help of that. Anyways, answer is 7. Yes, Sai Vikas, correct. Okay. Next one, gate 21 EE 1 mark question. Two discrete time linear time invariant system with the impulse responses h1n and h2n are connected in cascade. Okay, where delta n is the Kronecker delta. Okay, the discrete time delta function. The impulse response of the cascaded system. Now dear, what is the impulse response of the cascaded system? Whenever two systems are cascaded, the impulse response are convoluted. Very simple question. H1n convolution H2n. Okay, so anyways, 1 mark questions are mostly simple, but from signals, sometimes 1 mark good questions also you can expect. Okay, that is the reason I have broken the session into 1 mark and 2 mark separately. Then very soon I will take the 2 mark session. Very near time only. Maybe next 1-2 days only I'll try to take it. Okay, so what is H1n convolution H2n? And that's so simple impulses are given. What is H1n? Delta n minus 1. Then you have plus delta n plus 1. This much. Convolution with H2n. What is H2n? Delta n plus of delta n minus 1. Achha. Not only delta n convolution delta n, remember when any signal xn is convoluted with del n, answer is xn. Any signal convoluted with impulse, answer will be xn only. Okay, Ricky has the answer as of now B. Okay, let's check it out. Okay, so now see, delta x convolution delta is x, so delta convolution delta is also delta, but time shifting says that if any one signal in the convolution is shifted, output is shifted by the same measure. So delta n minus 1 convolution delta n will be delta n minus 1. Delta n minus 1 again with delta n minus 1 will be delta n minus 2. Okay, minus 1, minus 2 shift, plus delta n plus 1 with delta n. So that will be delta n plus 1, and last one plus delta again, delta n minus 1 plus 1. Okay, this will be n plus 1 minus 1. plus 1 shift here, minus 1 shift here. So this will be del n only. Okay, the net answer will be, okay, if I write this in sequence, delta n plus 1 is the first impulse, then plus delta n minus 1 plus delta n minus 2. As per their time stamps, I have arranged in the order, and the answer in that case, okay, is this one. Okay, however they arrange doesn't matter, the answer is B. Okay, answer is B. Correct answer, Ricky. Correct answer, Nitish. Okay, the correct answer is B anyways. Okay, dear. Next question. Consider a discrete time linear time invariant LTI system S, okay, where yn is equal to Sxn. Okay, that is output is Sxn, some operation on xn. Okay, now let S of del n equal to something given to you. What is the meaning of this statement? This is important. Gate 25 1 mark question this is. What is the meaning of this statement? Let S of del n equal to this parameter. Now see, when the input is xn, output is yn. See, clearly, you see the notation. When the input is xn, output is yn. Now, dear, tell me, whenever input to any LTI system is del n, the output is known as what? Okay, the output is known as what? Okay, S, okay, of del n. When the input is del n, the output is known as the impulse response, the output, the response to unit impulse input. This is Hn. Okay, this is Hn. This is known as impulse response of the system. Okay, so indirectly what they have given, impulse response, which is equal to 1 only at 3 instances. N equal to 0, n equal to 1, n equal to 2. This is equal to, like if you want, I can write it in the sequence. Okay, it is 1, 1, 1. The value is 1 only, but for what value of time? Starting from origin I will mark with the arrow, then 0 and then 1. Or better I can write down Hn in the form of impulses. Now what is this? Impulse at origin, del n. Next, right shifted impulse at n equal to 1 is right shifted impulse, del n minus 1. Next will be del of n minus 2. That's it. Now, okay, for any input xn, how output can be written? Okay, for any input xn, then at the same time we also know that output is any input xn convolution with the impulse response of the system. Okay, convolution with the impulse response of the system, right? Na? Okay, so what is going to be the answer then? Okay, xn convolution Hn. The first will be xn convolution delta n, xn. Xn convolution delta n minus 1, x of n minus 1. Because x convolution delta is x, na, I told you. Okay, time shifting applied. Now xn convolution delta n minus 2 will be x of n minus 2. Okay, this is what is the answer. This is what is the answer. So our answer is option number A, straightforward. Option number A, correct? Yes, Vasudha, correct answer, option number A. Option number A is what is the correct answer. Okay, Vasudha, correct. Okay. Anyways, next question. Gate 23 1 mark question. Which of the following statement is or are true? MSQ question this is. Okay. If a LTI system is causal, it is stable. No, these are two different concepts. We cannot say a system causal, so it is stable, or if a system is stable, it is causal. No. Okay. Okay. A discrete time LTI system is causal if and only if its response to step input un is 0 for n less than 0. A discrete time LTI system is causal if and only if its response to step input un is 0, okay, for n less than 0. Is this going to be right or wrong statement? That's what we have to figure out. Now see, normally what you know, a LTI system is causal. Normally what you study, the first thing about causality, if impulse response Hn equal to 0 for n less than 0. That's what you should know. Okay, but what they are telling, it's response to step input. They are talking about response to step input. Okay, also known as step response. Response to step inputs. Okay, step response, S of n. Okay. Now see, how do you calculate the output? Output is calculated as input convolution with impulse response. I am talking about which output? Step output, step response. The output when the input is unit step. Okay, so in place of input, I will write down un, and in place of Hn, I will simply write Hn. Now there is a simple property about convolution. Okay. If two signals are convoluted, their starting time will be added. Unit step starts from origin, everybody knows. Okay, unit step starts from origin. Hn the system is causal, Hn does not exist to the left. So where Hn starts? Hn starts either at origin or anywhere after it. Okay, it cannot start before origin. That is what the causality theory is. Na? It cannot start before origin. That is what the causality theory is for sure. Okay, so that's what we are going to check it out, right? Okay, it cannot start before the origin. It cannot start before the origin. Okay, so where can it start? Okay, it can only start. Okay, it can only start after origin. So that means I can say Sn is also 0 for n less than 0. So option number B is definitely correct. Option number B is something that is going to be definitely correct. Just a second. Yeah, option number B is definitely going to be correct. Okay, now let's talk about C and D. It's MSQ question, so we have to scan the other options as well. Okay, option number C. If a discrete time LTI system has an impulse response Hn of finite duration, then the system is stable. Now, what is the actual condition required for stability, dear? What is the actual condition required for stability? Let us see in terms of stability. What is the condition required for stability? Okay, let me check it out. Okay, system is stable if the impulse response is absolutely summable for a discrete time system. Okay, for continuous time system, we say that the impulse response must be absolutely integrable. Now, what do I mean by absolutely summable? Summation mod Hn. Summation of mod Hn must be finite for all values of n. Summation mod Hn has to be finite. Okay. Okay, dear. Summation mod Hn has to be finite. Now you see. Okay. A discrete time LTI system has an impulse response of finite duration, then the system is stable. Okay. Finite duration. It should have a finite duration or finite length. But they don't talk about the value of Hn. Now see. Suppose as an example, let Hn equal to finite duration only you want, it has some value 2, -1, 3, infinity 3, like this. Then what will you do? Okay, then what about summation mod Hn? Okay, if any one value is unbounded, the summation also will be unbounded, the system will not be stable. Okay, so what they're only telling in option number C, if the impulse response is of finite duration, the system is stable. No. Not necessary. It may have any one value which is unbounded. So summation also becomes unbounded, isn't it? Summation also clearly becomes unbounded. So C is not correct. Okay, C not correct. This tells you that C option not correct. Next one. If the impulse response, okay, now see, if the impulse response 0 less than mod Hn less than 1, that means every value of Hn or magnitude of Hn is between 0 to 1 for all n, then the LTI system is stable. But for all n, they have not put the bound or the range of n here. So take another example. Suppose Hn, what is the value of Hn? They are telling any value between 0 to 1. And let's assume a simple value 1 by 2. 1 by 2. 1 by 2. 1 by 2. Till infinity. Okay, till infinity. That means what I am telling is Hn is simply equal to half for all n. Hn is simply equal to half for all n. Now, if Hn equal to half for all n, then summation modulus Hn. Summation modulus Hn, half plus half plus half plus half plus half infinite times. Half plus half plus half plus half infinite times will be infinite only. Okay, so the system cannot be stable. Okay. System cannot be stable. Okay, right. So D also wrong. MSQ question, but only one answer correct. It is a MSQ question, one answer correct. Okay. MSQ question, one answer correct. Okay. Option C is related to FIR filter. I mean, yeah, whenever the impulse response is of finite length or finite duration, that is what is a FIR filter. But it is not stable as of now. Okay. It is not stable as of now. Okay. So D also wrong, C also wrong, only B answer. MSQ question, but only one option correct. MSQ with one answer correct. A causal and stable LTI system. A causal and stable LTI system with the impulse response HT produces an output YT for the input signal XT. Okay, see, a causal and stable LTI system, impulse response HT, output YT for the input signal XT. So what is the relation? We know that output signal YT is equal to the input signal XT convolution with the impulse response HT. That is what we anyways know. Okay. Now, a signal X 0.5t is applied to another causal and LTI, stable LTI system with the impulse response H of 0.5t. Okay, resulting output. Now, dear, if XT convolution HT is YT, simple convolution property X of AT convolution H of AT, same scaling, is actually given by 1 upon modulus A Y of AT. Okay, so now what is the input I am taking? 0.5t. Impulse response H of 0.5t. The answer should be 1 upon 0.5, that is 2 Y of how much? 0.5t. 2y 0.5t. Correct. 2y 0.5t. Next question. Suppose the signal yt is obtained by the time reversal of the signal xt, that is yt is x minus t. Okay, which of the following option is always true for the convolution of xt and ht? Okay, Sai Vikas said C. Yeah, correct, C. Yeah. Simple question. Convolution of xt and yt. Gate 24 EE 1 mark question. Convolution of xt and yt, but what is yt? Yt is x of minus t. Now, dear, a signal, apply the simple logic, a signal convoluted with its mirror image is also a way to calculate, this is also a way to calculate the correlation. Okay, we can call this function as Rxx tau, and correlation is always a even symmetric function. Apply the simple logic, treat it as a 1 mark question, finish the question. Okay. The convolution of a signal with its mirror image is also helpful in finding the autocorrelation. So the net result will be autocorrelation function of x, and autocorrelation is always a even symmetric function. Option number A. Correct, Sai Vikas. It is autocorrelation. Option number A is the correct one. Okay, dear. Next question. Gate 23 EE 1 mark. This is 1 mark, but this is a good question. Okay. Anyways, gate 23. If you are an electrical student, you must know gate 23 has been one of the lengthiest and the challenging paper for electrical students in the past 15-20 years if you compare. Okay. So, no problem. Many questions were time taking only, even 1 mark. It's not difficult, but 1 mark according to 1 mark. Okay. See, because, question is for the signals xt and yt shown in the figure. Zt's xt convolution yt is maximum at some time t equal to t1. What is that t1 equal to? What is that t1 equal to? Okay, so now one of them is a ramp line, is a straight line from 1 to 5. One of them is a rect function. Okay, if it was rect convolution with rect, we already know the results. Either a triangle or trapezium based on the duration of the rectangle signal. Okay, but yeah, how to deal with this? If any random functions or graphs are given, you can think about graphical convolution. Okay, what is convolution then? Okay, see. Zt, which is xt convolution with yt, okay, or can also be reversed as yt convolution xt, and the formula is integral. If I write down the formula for yt convolution xt is y tau x of t minus tau. Y tau x of t minus tau. Now see, why did I reverse? See, convolution is commutative, you can swap, but why did I swap? Because see, x being a simple curve, simple symmetric rectangle, it will be easy to apply shiftings. Okay, shifting or folding on the x signal. Okay, y I am not changing. So y is as it is, y tau, x of t minus tau, x I will change. Okay, and then we can say that, this result zt, the convolution, as per the idea of graphical convolution is area under, because integral is nothing but area under y tau x of t minus tau. Y tau x of t minus tau. Now keep listening to me. I need to first make this y as a tau function, no problem. Okay, so let this be tau. Here only I will change, and let this be tau. This is y tau. Okay, but I want x of t minus tau. Okay, now keep listening here. Suppose this is x tau. Suppose this is x tau. But because it is symmetric, I am making it as a tau function. But anyways, it is symmetric now, identical to left and right. Okay, 1 unit left, 1 unit right, same value on either side. Okay, So it is definitely what? Okay, it is definitely what? Symmetric function. Symmetric function means this is also equal to x minus tau. X tau or x minus tau are same here. X tau or x minus tau are same here. But what I want, x of t minus tau, at least x minus tau is obtained. Okay, see dear, when you want to draw x of t minus tau, t minus tau. Now this is with respect to tau. Actually the x axis is tau axis. Okay, so I shall write it like this. Let me take minus outside, tau minus t. Is this okay now? Okay, this will become plus t and this will be minus tau. Okay, so I will shift it by t units. Okay, I will shift it by t units. So what is going to be my resultant waveform? I am going to draw the xt minus tau waveform, and that should be looking like shifted by t units. Okay, if it was 1, here it goes to 1 plus t, or let me write it as t plus 1. Minus 1 plus t, or I can write it as t minus 1. Okay, so it is shifted by 2 units. Okay, it can be right or left shifted based on the time, because t can take any value, na, plus minus anything. Okay, Sai Vikas has some answer, that is 4. Okay, so now we need to consider the product of these two. The important point is we need to consider the product of these two. Now, the signal xt minus tau is from t minus 1 to t plus 1. But the signal y tau is from 1 to 5. Is from 1 to 5. Okay, so what can be the picture here? The picture can be, okay, let me take simple instances here, okay. Let me take the simple instances here. Let us take this signal. Let me take the signal separately, okay. Let's up here, then only it is helpful for them. I'll adjust it somehow. I thought it will be pasted here. Just a second. Okay, anyways, what is there? No problem. Let's not waste time. Let's do it then. Okay. So I was just trying to take this picture. So there can be 4 instances. I wanted to draw the 4 of these pictures. See, what do I want is come here. Replicating y tau. Understand this question, because this one question is helpful for understanding graphical convolution as well. I am explaining you step by step. This is 5, 3, this is 1. Okay, the amplitudes are 2 and minus 2. This is 2 and this is minus 2. Now, what is the first instance I am taking? The other signal, that is xt minus tau, which is from t minus 1 to t plus 1. Okay, which is from t minus 1 to t plus 1. Okay, it may be possible, okay, based on the value of t, it may be possible, this signal has the amplitude 1 unit. Okay, that this is t minus 1, t plus 1. Because t is time variable and time can be anywhere from minus infinite to infinite. So the idea is this rectangle can be swapped, can be moved, okay, from minus infinite to plus infinite. Okay, and the first instance is, the first instance is so that the t plus 1 is less than 1. Okay, the t plus 1 is going to be the less than 1. Okay, and then there is no overlap. They cannot be multiplied, because wherever this is 1, the other is 0. The other starts from 1. Wherever the other one is non-zero, the first one is 0. Okay, so for t plus 1 less than 1, the first case, okay, the t plus 1 less than 1, what is going to happen? T less than 0. T plus 1 less than 1 means t less than 0. Okay, means t less than 0. Okay, answer is going to be 0 because the product of them, what is the product? Y tau x t minus tau. The product will be 0. Okay, and hence the area under them. Okay, so the product itself is 0, area also 0. Okay, the product itself 0, the area also is going to be 0. Right, the area is also going to be 0. Now, second instance, what can be the second possibility? The second possibility would be, the second possibility is, anyways, y tau is fixed. I have not changed y tau. This is 5, this is 3, this is 1. Okay, but the other one, okay, t minus 1 to t plus 1 is here. This is t plus 1, this is t minus 1, this is 1. Okay, so some overlap can come. Okay, some overlap can come and some area will come up. Now see, I would have completed the entire story if I wanted the convolution. If I wanted the complete convolution. Okay, I'm just giving you a hint how to solve it. Now see, the next possibility that has been taken here is t plus 1 is greater than 1. Okay, but t plus 1 is less than 3. Okay, it is between here. So that means what will be the condition on time? T greater than 0, t less than 2. Okay, so then some area will come. Okay, then some area will come. Correct? I don't want this area. Yes, I would have calculated this area if I wanted the convolution for all values of time. Keep listening. If I wanted the convolution for all value of time. Okay, but I want that the result of convolution is maximum at some time. What is that time? Now see, if you keep shading this, important point to note is, what is the width of this rectangle? What is the width of this rectangle is 2 unit. Okay, this is 2 unit and this, okay, this negative portion of the line is also for 2 unit. This positive portion of the line is also for 2 units. So there will be a moment you keep sliding it, it will exactly overlap here because this is also 2 unit, this is also 2 unit. But that is going to give negative area because see, this is anyways 1. The other one will contribute to negative area. I want the maximum area. The maximum positive area only I will assume. Na? Maximum positive area I will assume. So I will have to place this here. I will have to place this here from 3 to 5. Okay. Okay. So maximum area condition will come. Maximum positive area will come if the rectangle overlaps with the positive part of y tau. Okay, and to overlap with the positive part of y tau, that means what should be t minus 1? It should be 3. What should be t plus 1? It should be 5. T minus 1, 3, t plus 1 equal to 5. That means from either of them, t equal to 4. And that is what is T1. That is what is T1. Maximum area, maximum convolution, because area, the convolution is area under y tau x t minus tau. That's what I have taken. Okay. Okay. So this is going to be 4. Okay. The answer is 4 unit. Good question for 1 mark. I told you. So good question for 1 mark. Gate 23 double. But don't worry. Usually you don't get this level question for 1 mark, but GATE 2023 already I told you, not only for this question, the entire EE paper 2023, okay, was actually a lengthy, calculative and a better, good paper. Okay, so, okay, it was there for all subjects, but usually 1 mark, as you saw earlier, are usually direct questions. If not very direct, at least some fundamentals required, but not that much of length required to solve, but okay. Next question, GATE 25 EC 1 mark. Conceptually, this is again a good question. Okay. Consider the discrete time system shown below with the input xn, output yn, okay, and then in the figure, h1n and h2n denote the impulse response of LTI subsystems. So both of these subsystems are LTI, okay, LTI subsystems 1 and 2. Also del n is the unit impulse function and b greater than 0. Okay, assuming h2n equal to delta n, the second one, h2n is delta n. The overall system denoted by the dashed box is how much? Okay. Sorry, I think there's a typo error. The question doesn't say that h2n is delta n. Assuming h2n not equal to delta n. I remember this question. Assuming h2n not equal to delta n. That is the actual question. Okay. h2n not equal to delta n. Okay. Yeah. So then let's start solving it. Okay, yeah, let's come up here. Okay, so what is mentioned here? Now see, because if any system is LTI, the output of the system can be obtained by convolution. Convolution is applied for LTI systems, right? Okay, so what is the output here? The output here can be written as input xn convolution with the impulse response h1n. Then what is going to be the output here at this node? Okay, because it's simple adder summer, so plus b del n, the above one, xn convolution h1n plus b del n. Now again, this goes as the input to the LTI subsystem 2. Okay, LTI subsystem 2. Okay, so then what is going to happen? Then what is going to happen? Okay. This particular is going to be convoluted, okay, with the impulse response h2, xn convolution h1n plus b del n. Whole convolution with the impulse response will give the output. Okay, will give the output. Whole convolution with h2n. Okay, and then output yn will be minus b del n. Okay, so I'll directly call this as the output equation yn. This yn, okay, is this much of the part. Okay, and then after this much of the part, okay, minus b del n. Minus b delta n. Okay, like this. Okay, so now what is the output versus input relation? Let me just simplify this equation. Yn equal to, now see, first is xn convolution h1n convolution h2n. I will open the first bracket. It is xn convolution h1n convolution h2n. Okay, then plus b del n convolution h2n. See, what is b del n? You know, anything I told you already, we solved the question on to. H2 convolution delta should be h2, h2n. Convolution of any signal with impulse will replicate the signal. Okay, then minus b del n. And this is why they have clearly mentioned that h2n is not delta n, because if h2n was by chance delta n, then this part will become 0. Okay, now for a moment, let us assume this h1 convolution h2. Okay, the convolution of this signal will be some signal, suppose hn. Then what is the input versus output relation? Then I can write down the output as input xn convolution hn. Okay, if the output was only this much, then I can 100% say the system is LTI, because output equal to convolution of input between input and impulse response is for LTI system. But I have some additional terms, plus b h2n, okay, minus b del n, okay, minus b del n. Okay, what is this, dear? Okay, output depends on input, but also it depends on separate function of time. What is this? Delta n is a function of time, h2n is a function of time, separate function of time. Okay, time varying. I told you this already in the beginning questions. Separate function of time, the output has to be time varying, the system has to be time varying. The system has to be time varying. Okay, then will it be additive in nature? Any separate terms, okay, either constant or function of time. See, for any input x1, output will be y1 equal to x1 convolution h plus something. Okay, plus something. Let's say this something, is, you know what, let me name it. Suppose this is some factor p. Okay, for input x2, y2 will be x2 convolution h, but that something will remain as it is, p. So if I take the input as x1 plus x2, output will be x1 plus x2 convolution h plus something that will still come. Now, is it y1 plus y2? See, if y1 plus y2, what should be the result? x1 plus x2 convolution h plus p, 2p. But here it is only plus p. Okay, so this is not clearly y1 plus y2. You got my point? Non-additive, non-linear. Non-additive, non-linear. It is non-additive, so non-linear. That's it. Okay, so it is not linear as well as not time invariant. So non-linear and time variant, answer is D. Answer is D. It is not linear also, it is not time invariant also. So non-linear and time variant, option is D. Okay, next. Okay. In the table shown below, match the signal time with its spectral characteristics. Okay, let's do it. Okay, signal time with the spectral characteristics. Okay, this is direct question that you must know. Okay. What is the first? Continuous and aperiodic signal. Okay, are described by the Fourier transform. Okay, continuous and aperiodic signal, they will have Fourier transform x omega. Okay, which is a continuous function, but it is not periodic. Okay, the Fourier transform in general is not periodic. So, the first goes with A. Okay, then second, continuous and periodic signal. Okay, the spectrum of continuous and periodic signal is discrete in nature. Okay, CK, only defined for integral values of the K. Even if you want to write down the Fourier transform expression for periodic signals, continuous periodic signal, you get impulses, okay, only at the fundamental frequency, okay. So you get, omega naught, 2 omega naught, 3 omega naught terms, okay, but not continuous frequency. So this is definitely discrete, but not periodic. Discrete and aperiodic, C. Okay. Then discrete and aperiodic signal, okay, xn, they are described by the dtft x of omega, and dtft is always a periodic function, period of 2 pi. Okay, it is a periodic, continuous periodic function, continuous and periodic function B. Okay, and discrete and periodic signals. Okay, discrete and periodic signals. Okay, described by the discrete time Fourier series. Okay, where the discrete time Fourier series coefficients are always periodic. Ck for discrete time signal. Ck plus n is Ck. Ck plus n is Ck. Okay, so this will again be discrete but periodic. So this will go with D. This will go with the D. Okay, so ACBD. Option number B. Okay, the matching is like this. ACBD. This is the sequence to be matched. Correct answer B. Time because recheck it, not D. Okay, I think last two you have swapped it. Let's check it out. Okay, I hope you have got it. Okay. Okay, this is, this is what? This is CTFT. This will be described with CTFS. Okay, this is DTFT. Last one, DTFS. This is something, if you have studied these topics, you should know these characters. Next one. Okay, so previous one was gate 23 EC 1 mark. This is next gate 25 EC 1 mark question. Okay. See here. A simple question, if you know how Dirichlet's condition come, based on the same idea, you can write this. Consider a continuous time real valued signal ft whose Fourier transform is given integral ft e power minus j omega t dt. Okay, which one of the following statement is always true? Okay, let's find it out. Which one of the following statement is always true? Now see, the options are clearly talking about magnitude of f omega, modulus f omega. So see, what is modulus f omega? First, let me apply the modulus on both the sides of the Fourier transform formula. Integral minus infinite to infinite ft e power minus j omega t dt. Okay, now see, modulus of integral, okay, is always less than equal to integral of, okay, individual modulus, integral minus infinite to infinite, okay, modulus of ft e power minus j omega t dt. Okay, just like you treat this way, na? Modulus of a plus b, okay, less than equal to mod a plus mod b. Okay, modulus of whole summation is less than equal to summation of individual modulus. Same thing applies to integral. Okay. Now, what is the modulus for e power j theta? Okay, for this term, magnitude of e power j theta is anyways 1, na? Root over cos square theta plus sin square theta. Okay, so this is going to be integral modulus ft dt. Only this is going to be left. Okay, so what is modulus of f omega? Less than equal to integral mod ft dt. Option number A, straightforward. Option number A, straightforward. Yes, Sai Vikas, correct. A. Sheikh, it's going to be A. Just recheck it once. Okay, which PDF are you referring to, Ashrita? You please message me personally in Telegram. I don't know which PDF you are referring to right now. Yeah, next question in just a second. Yeah, come on, take this question, gate 23 EC 1 mark question. Simple question, Gaussian function. Yeah, let's go and check this answer. Okay, how much? Shake. Sai, Vikas, Raj and Sheikh, everybody say answer A. Yeah, simple one only. See, what is the formula I wanted to use is Gaussian pulse e power minus at square has the Fourier transform root over pi by a e power minus omega square by 4. For our question a equal to 1, so root pi e power minus omega square by 4. Okay, it is C. What is the mistake? It is C, guys. It is C only, not A, not B. It is C. E power minus at square root pi by e power minus omega square by 4. A direct formula you should know. It's a 1 mark question anyways. Okay, it is answer C actually, root pi e power minus omega square by 4 by putting a equal to 1. Okay, dear. Next question. Let's go and check the next question. The Fourier transform xj omega of the signal xt equal to t upon 1 plus t square whole square. T upon 1 plus t square whole square. How much is the Fourier transform for this signal? Okay, let's check it out. Okay, now see here. Actually, I'll have to start this question with the Fourier transform for e power minus a mod t, or I'll take a equal to 1. E power mod t minus mod t Fourier transform. If I generally write down e power minus a mod t, two-sided bounded exponential signal, okay, 2a upon a square plus omega square, a positive for bounded exponential signal. Okay, 2a upon a square plus omega square. So if I am taking a1, so 2 upon 1 plus omega square. 2 upon 1 plus omega square. Okay. Now, furthermore, I want 1 plus t square whole square. So what will I do? First, I will apply the t times property here. What is that t times property? Okay, the t times property is for any function t into xt, the Fourier transform frequency differentiation, you can also call it as frequency differentiation, Fourier transform is given by j d by d omega of x omega. Correct? For txt, the Fourier transform is, okay, j d by d omega of x omega, okay, of this above function, 2 upon 1 plus omega square whole square. Yeah, so now when I differentiate this, okay, 2 is constant, 1 upon x derivative minus 1 by x square. So I'll get first of all minus 2 by 1 upon omega, 1 plus omega square whole square. Then by chain rule, if you differentiate the denominator, you will get 2 omega. Okay, so I'll write down the result here. For t e power minus mod t, okay, for t e power minus mod t, the answer is, okay, minus 4j omega upon 1 plus omega square whole square. So at least I've got this function. I wanted this t upon 1 plus t square whole square. I have omega upon 1 plus omega square whole square. Next is what? Next is duality. Okay, next is duality to be applied. I have some answer. Vasudha says answer as A. Okay, let's check it out. Now, if I am going to apply duality. Okay, duality. Okay. Transform of transform. So suppose if omega now is replaced by t, I'll get minus 4jt upon 1 plus t square whole square. This will have the transform 2 pi, okay, x minus omega. You have to put t equal to minus omega here to 2 pi minus omega e power minus mod minus omega. Okay. Now I only want in the question t. I only want t upon 1 plus t square whole square in the question. So minus 4j will be divided to the right. Minus 4j will be divided. So this becomes minus 2 pi omega upon minus 4j e power minus modulus of minus omega is modulus omega. Modulus of minus 1 is same as modulus of 1. Okay. So now all the cancellations done. Okay, minus minus cancel, but 1 upon j is further minus j. Let me see in the options. In the option, denominator only has the j. Okay, so then let the j be in denominator. 2 pi by 4, or that is pi by 2j e power minus mod omega should be the answer. Pi by 2j e power minus mod omega. Answer is option number C. Option number C. Okay. Pi by 2j. Sorry, A only. A. Sorry. Omega also is there. Na? I have not written this omega here. Correct. Omega e power minus mod omega. Answer is A only. Correct answer. Vasudha, Sai, Vikas, correct. A. Okay, the answer is A. Next question. So this was a duality and fundamental properties. Okay, like frequency differentiation, T times property. Okay, gate 22 ECE 1 mark question. Decent for 1 mark. Gate 24 EE 1 mark. Okay. Yeah. Again, this is a small but good question for 1 mark. A little thoughtful. Not lengthy, but little thoughtful. x omega be the Fourier transform of the signal xt e power minus of t power 4 cos t. What is the value of derivative of x omega at omega 0? Okay, derivative of x omega. Okay, so let's say the derivative of x omega, d by d omega of x omega is some signal y omega. I want the value of this at 0. The question is y 0. Okay, so dear, the simple property y 0, that is the value of the Fourier transform at 0 frequency, is nothing but area under yt signal, or integral of the yt signal. But what is going to be yt? Okay, what is going to be yt? Okay, because xt is given to me. Okay, just now in the previous question we used the differentiation property, the frequency differentiation. Same frequency differentiation is only coming up here. So see, I'll solve it here. Xt, some signal, has Fourier transform x omega, then the signal t into xt. This has the Fourier transform j d by d omega of x omega. So if I only want d by d omega of x omega, what will I do with the j? J I will divide on the left. 1 upon j is minus j. So I will write directly like this: minus jt xt has the Fourier transform d by d omega x omega. So if this much is y omega, okay, this has to be yt. Its corresponding time domain representation yt minus jt xt. Okay, so I'll write it here now. Integral minus infinite to infinite yt. Now what is yt? Minus jt xt dt. Now see, integral minus a to a. Whenever you see the question of the form integral minus a to a, think about symmetry, because the question, okay, in terms of integral is going to be complicated. T xt, where xt is e power minus of t power 4 cos t. But you see here, what about x minus t? Okay, t power 4. So even if you replace by minus t, no effect. Minus t power 4 is same as t power 4. Cos minus theta is also cos theta. Okay, so x minus t is going to be xt. That means even symmetric. Okay, so xt is even, but t power 1, odd function. Odd into even is odd. Integral minus a to a for odd function. Integral minus a to a, whether infinity or a, anything. Integral minus a to a, symmetric limit for any odd function is always 0. Question finishes here. That simple thought process has to come. And not only for this question, I keep telling students many times that whenever you see an integral of the form minus a to a, whether it is a simple function or complicated function, but when you see minus a to a, the first thing that should strike in the mind is symmetry. If the function is even or odd symmetry, then it may be simplified. Okay, so its answer is 0 right now for the question. Okay, gate 24 EE 1 mark question. Next one, gate 23 EE 1 mark question. The Fourier transform x omega of the signal is given by x omega equal to 1 for modulus omega less than omega naught. It is 0 for modulus omega greater than omega naught. So what is the sketch? Modulus omega less than omega naught. That means either 0 to omega naught or 0 to minus omega naught. Let me write this way. Because this side also magnitude less than omega naught, 0 to minus omega naught, magnitude will be less than omega naught only, correct? So what is x omega? In a sense, is a rectangular pulse. X omega is a rectangular pulse. What rectangular pulse? This one. Minus omega naught to omega naught, it is 1. Okay, it's just like a ideal low pass filter. Ideal low pass filter. Okay, so what is the time domain definition of ideal low pass filter? What is the signal xt? Okay, what is the signal xt? It is given by sine omega ct. Omega c means omega naught here, cutoff frequency. Sine omega ct upon pi t. Okay. Or it is also given by the sampling function. You can also write it as omega naught upon pi. Omega naught I multiply here, I also multiply in the denominator, so that I get sine theta by theta, which is sampling function. Sampling theta. Okay, which of the following statement is true? Now tell me. Xt tends to be impulse if omega naught, okay, if omega naught tends to infinity, okay, option number A analysis, if omega naught tends to infinity, then x omega will become 1 for all omega. I can say na x omega 1 for all omega if omega not infinity. So from minus infinity to infinity x omega 1, whose Fourier transform is 1? Impulse function, simple. Then xt will be del t. Then xt will be del t, finished. So xt tends to be an impulse as omega naught tends to infinity. This is MCQ question. One option correct, go forward. I will explain you other here, but in the exam I am telling one option correct, go forward. MCQ question. If it is MSQ, you have to give the thoughts. Okay, you have to give the thoughts, you have to check the others. Okay. Now, x naught decreases as omega naught increases. Okay. Now see, what is the value of x naught? See, I'll write down this function here. What is the xt function I have got is omega naught by pi sampling omega naught t. Okay, omega naught by pi sampling omega naught t. Okay. Now see, x naught, what is going to be the value of x naught? Is simply omega naught by pi, because sampling 0 is 1, sin theta by theta, limit theta tending to 0, sin theta by theta is 1. Okay, so if omega naught increases, x naught will also increase only, na? X naught will also increase only. Okay, so this is wrong. Anyways, only one option correct. Now at t equal to pi by 2 omega naught, what is xt? Okay, next is t equal to pi by 2 omega naught. Okay, what is xt? Okay, let me use this because sin theta values are easy to calculate. Now let me use this. Sine of omega naught t. What is omega naught? Oh, sorry, what is t? Pi by 2 omega naught divided by pi t. Divided by pi t. Now, omega naught cancel. Pi by 2. Sin pi by 2 is how much? 1. So, answer is 1 by pi t. 1 by pi t. And then again, here also I will put t. Na? 1 by pi t. What is t? Again pi by 2 omega naught. Okay. So the answer is actually 1 upon pi square by 2 omega naught, or 2 omega naught by pi square. 2 omega naught by pi square will come, correct? So it is nowhere minus 1 by pi or plus 1 by pi at t equal to pi by 2 omega naught. Correct. Now what I have done is sin omega naught t, this formula, sin omega naught t by pi t. Okay, t equal to pi by 2 omega naught here and here both. Okay, here also you have to put, na? Okay. Correct. So C and D are wrong anyways. I told you. The answer is 2 omega naught by pi square. So only A option correct. Okay. Okay, VK for gate 27 offline batches will start from February. But yes, if you want to start early, you can start from December. Yes, you can visit our office and from the fresh subject you can start, because anyways any subject will be covered to you from the scratch only. So yes, that is doable for you. That is easily doable for you. Consider a real valued baseband signal xt limited to 10 kilohertz. The Nyquist rate for the signal signal yt equal to xt into x1 plus t by 2 is how much? Okay, the Nyquist rate for the signal yt equal to xt into x of 1 plus t by 2. Now see here. Okay, if xt is band limited to 10 kilohertz, that means for xt the maximum frequency component is 10 kilohertz. Okay, for x of t by 2 plus 1. For x of t by 2 plus 1. Now, the point is, if you only do the time shifting, okay, time shifting, no effect. Time shifting has no effect on the highest frequency component or the bandwidth of the signal. Okay, now time scaling, this definitely affects. How much? Okay, x80, the frequency, the highest frequency component also become 8 times, half of this. Okay, the FM will become 1 by 2 into 10k. See, I'll tell you the simple logic for this. Simple logic is, when you talk about xt by 2, understand this. Okay, the Fourier transform becomes, okay, 2x2 omega. The Fourier transform is 2x2 omega for x of 80. 2x2 omega. X of 80, 1 by mod a x omega by a, Fourier transform property. Now that means there is compression in the frequency domain. What is 2 omega? See, xt by 2 in time domain 1 by 2 expansion, but in frequency domain 2 omega, the scaling factor greater than 1, compression. Compression in frequency domain, that means the signal which was band limited to 10 will be compressed and will be coming up to 5 kilohertz. That is what I have written here directly, half into 10. Okay, half into 10. Okay, so that is what, as a standard result, if you want, you can note down. Okay, if xt has the highest frequency component fm, x of at will have the highest frequency component of afm or modulus afm. Negative a will not affect it. Okay, so now when two signals are multiplied, okay, then their bandwidth or highest frequency components are added, because multiplied in time, convolution in frequency, the ending points, the fm points will be added. Okay, so when these two signals are multiplied, the highest frequency component will become 10 plus 5, that is 15 kilohertz. So Nyquist rate, we all know, is twice of this value, 30 kilohertz. Nyquist rate is twice of fm. Answer is 30 kilohertz. Option number D. Option number D, 30 kilohertz. The Nyquist rate is 30 kilohertz. Okay, next question. Consider two 16-point sequences xn and hn. Let the linear convolution of xn and hn be denoted by yn. Okay, while Zn denotes the 16-point inverse discrete Fourier transform of the products, okay, of the 16-point DFTs of Xn and Hn. What is the value of k for which Zk equal to Yk? See, simple property of convolution actually. Okay, the linear convolution, okay, Xn and Hn is Yn. Zn is the 16-point inverse. Now see, I have to only describe Zn to you. What is Zn? Is the 16-point IDFT, inverse discrete Fourier transform of the product of the DFTs, 16-point DFTs of Xn and Hn. Okay, so suppose Xn DFT Xk, Hn DFT Hk. Okay, right. Now, if Zn is the IDFT of Xk, Hk, multiplied, Xk and Hk multiplied in what? Multiplied in frequency domain. So what should be happening in time? Convolution. Okay, which convolution? Circular convolution. DFT, IDFT both are periodic. The convolution operation is represented by circular or periodic convolution. Okay, the Zn is Xn convolution Hn. But where is Yn? Yn is simply clearly mentioned as the linear convolution of Xn and Hn. And here, always and always, okay, as I have taught you, always and always the linear convolution and circular convolution are equal. Okay, the sum by column method, if you see the last column, they are equal always at n equal to capital N minus 1. Capital N means the length of the signal. We are talking about 16-point DFTs, na? Okay, so here n will be equal to 15. Okay, for 15 or k, okay, let's call it in the k form, k equal to 15. Yes. Yes, correct answer, Raj. It is going to be D. Okay, always the linear and circular convolution will match at n minus 1. It is always going to match at the n minus 1. Okay, dear. Next question. For a causal discrete time LTI system with the transfer function 2z square plus 3 upon z plus 1 by 3, z minus 1 by 3, which of the following statement is or are true? Gate 24, EC 1 mark, MSQ question. Okay. Now see, initial value, final value, minimum phase system, stable or not stable. This is what is required. Okay, see here. I'll have a simple conclusions here. Okay, first let me write down the poles of the system. Okay, what are the poles? Okay, Z is equal to minus 1 by 3 and plus 1 by 3. Z is plus or minus 1 by 3. Okay, for both of them, modulus of Z is less than 1. Okay, that means both the poles are inside unit circle. Both the poles inside unit circle. Okay, and if all poles of a causal system, okay, are inside unit circle, the system will be stable and the final value will be 0. This is something that you should directly say. Okay, the system is stable, correct. Okay, the final value is 0, correct. Okay, two options are anyways correct, but I have to scan all. MSQ means you have to scan compulsorily all options. Okay, now is it minimum phase? Okay, what is the condition required for minimum phase? Poles as well as zeros inside the unit circle. Minimum phase means all poles as well as zeros inside unit circle. Okay, now what is the zeros? Zeros I will write separately. Okay, zeros means 2z square plus 3 equal to 0. So z equal to under root of minus 3 by 2. Under root of minus means j, plus minus j, root 3 by 2, under root 1.1, under root of 1.5. Okay, but what is the magnitude of z? Under root of 1.5 will be definitely greater than 1. So magnitude of z greater than 1 means the zeros are outside unit circle. Okay, so B option is wrong. Okay, it is not minimum phase. Okay, the initial value of the impulse response. Now, what is the initial value formula? Okay, initial value theorem for causal signal h0 is nothing but limit of z tending to infinity h of z. Limit of z tending to infinity h of z. What is h of z? Is 2 z square plus 3 upon denominator. If I multiply a plus b, a minus b, I will get a square minus b square, z square minus 1 by 9. Limit z tending to infinity. Okay, the highest term is z square, numerator coefficient 2, denominator coefficient 1. Or you can solve by L Hospital rule. Anyways, you have to solve the limit, that is your choice. Okay, you'll get the answer is 2. That means option number A is also correct. A, C, D, 3 answers are correct for this MSQ question. A, C and D, 3 answers are correct for this particular MSQ question. Okay. A, C, D. Okay. Next question. Okay. Gate 24 double E 1 mark. Okay. Gate 24 double E 1 mark. This one is easy only. Ut is the unit step function, then the ROC, region of convergence. Okay, for the Laplace transform of the signal xt equal to e power t square, ut minus 1 minus ut minus 10. Again, as I described you earlier also, this signal, subtraction of two step signals of equal magnitude will be a rectangle starting at 1, ending at 10. Starting at 1, ending at 10. That means I can now write down signal xt equal to e power t square only from 1 to 10. And that means the signal is going to be finite in duration. Whatever the signal, but it only exists from t equal to 1 to 10. Doesn't go to infinity, doesn't go to minus infinity. Finite duration signal. What do you know about the ROC of finite duration signal? Okay, for finite duration signal, ROC is always entire S-plane. ROC is entire S-plane. That means any value of sigma can be taken from minus infinite to infinite. Minus infinite to infinite. Okay, yeah, for previous one, Raj and Shadow had given the correct answer, ACD. Sorry, I could not see that. Okay, and Shadow, it's not D here, it's A. The sigma doesn't depend on this time range, na? Yes, correct. For this one, it is A. Sai Vikas correct. Shadow now correct. Yes, okay. Next question. Okay, gate 22 ECE 1 mark question. Let x1 t equal to e power minus t ut and x2 t equal to ut minus 2, where u dot denotes the unit step function. If yt denotes the convolution of x1 t and x2 t, then limit t tending to infinity yt will be how much? Limit t tending to infinity yt will be how much? Let's solve this. Okay, yt is the convolution of x1 t and x2 t. Okay, now see, dear, first of all, if yt is convolution x1 t with x2 t, okay, let's solve it simply by converting to the S domain, because in S domain multiplication will happen. Ys will be x1s multiplied by the x2s. Okay, now final value theorem, limit of t tending to infinity yt is nothing but limit of s tending to 0 s into ys. Final value theorem, limit s tending to 0 s into ys. Now what is ys? What is x1s? E power minus t ut Laplace transform, 1 upon s plus a, 1 upon s plus 1 multiplied by x2s, ut minus 2 Laplace. Okay, let me write it here, ut 1 by s. Okay, for unit step we all know Laplace 1 by s. For ut minus 2, 1 by s e power minus 2s, 1 by s e power minus 2s. Okay, so now see, this s and s will get cancelled. I will have the answer. Okay, let me rearrange it first. I'll write it this way, s 1 upon s plus 1, and then the third term is 1 minus e power minus 2s by s. Okay, so this sn cancel. Now you put s tending to 0, 1 upon 0 plus 1, 1 minus e power 0, but e power 0 is 1. 1 minus 1 upon 1, the 1 minus 1 is 0, answer is 0. NAT question, answer is 0. Let me see, anybody? Yes, Sai Vikas, correct answer. Shadow, correct answer A. Yes. Good going. Option number A is the very correct answer. No, sorry, not option number A. 0 is the correct answer. It's an NAT question. No options are there. NAT question. Next one. Gate 25 EC 1 mark MSQ question. Simple one. Actually a simple one. Okay. What it is there? Let xn be a discrete time signal whose z transform is xz. Which of the following statement is or are true? Okay. Which of the following statement is or are true? The discrete time Fourier transform of xn always exists. No. Okay. The discrete time Fourier transform exists if the ROC contains unit circle. If the ROC contains unit circle. Okay. Always exists? No. The DTFT, you know that. And same thing in continuous domain, what do you say? The CTFT, continuous time Fourier transform exists if the ROC includes imaginary axis. In discrete domain, ROC includes unit circle. Okay. Now, the region of convergence, so A wrong, C right. Now second, region of convergence of xz contains neither pole nor zeros. Wrong statement. ROC cannot contain pole, correct. Nothing about 0. 0 may be inside ROC, outside ROC. No, ROC is bounded because of poles. ROC cannot contain poles. So this particular statement is wrong. Okay. If they only told ROC cannot contain pole, that is wrong. But they say cannot contain pole or zeros, that is wrong. Okay, up to pole it is okay. It cannot contain poles. Yes, that should be right. Now D option. If xn equal to alpha del n, where del n is the unit impulse in alpha scale, then ROC is the entire z plane. Yes, na. What is going to be the z transform of this signal? Alpha del n z transform is 1, so it is always 1. Alpha into 1. Del n z transform is always 1 for any value of z. It is equal to alpha. Here the answer is alpha for all z. That means ROC is entire z plane. There is no condition. There is no pole. Is there any pole? No, the z transform is constant. Okay. So there is no pole, and no pole means ROC entire z plane. ROC is confined because of poles. So D also correct. C and D. No name, we cannot finally 100% comment right now, because lot of variations are happening in PSU's recruitment. But yeah, vacancies will come. Okay, vacancies will come. Okay, vacancies will come. But whether with gate, without gate, that you have to see. Vacancies will come for ONGC, don't worry. That will anyways most likely come. Option A, what is there to explain, Sai? Because option A says that DTFT always exists. No, see, what is the DTFT actually? DTFT. What is Z transform formula? Z transform formula, xz, summation, xn, z power minus n, minus infinite to infinite. Okay, where z is the complex variable r e power j omega. By putting r, which is mod z equal to 1, okay, z becomes e power j omega, and then you get the DTFT formula. Okay, that becomes x of z. Z is how much? E power j omega, x e power j omega. Summation minus infinite to infinite, x of n, z power minus n becomes e power minus j omega. And this is what the DTFT formula you study, na? Okay, so what is this DTFT? It is the value of z transform at z equal to e power j omega. Or I can say, okay, this is the value of the z transform by putting z equal to e power j omega. Okay, but if ROC, now every z transform is only defined within the ROC. Okay, so if ROC contains what? If ROC contains this condition, because you are converting z to e power j omega, that means you are assuming mod z equal to 1, r equal to 1. Okay, if the ROC doesn't include mod z equal to 1, you can't use this value. If you can't use the value, DTFT cannot be defined. Na? Okay, so if the ROC includes unit circle, then only the DTFT is defined. Okay, so gate 25 EC 1 mark MSQ question. This was 2 answers correct, C and D. Okay, the next question, gate 23 EE 1 mark. Okay, Sai Vikas now? Yeah. Option, no, gate 23 EE 1 mark. The z transform of a discrete time signal xn is given to you 4z upon z minus 1 by 5, z minus 2 by 3, z minus 3 with ROC equal to R. Which of the following statement is true? The discrete time Fourier transform of xn converges if R is mod z greater than 3. See, the DTFT converges. Just now I explained you if ROC includes mod z equal to 1. Okay, now if the ROC is mod z greater than 3. Now if mod z greater than 3 means mod z equal to 1 not allowed, na? Okay, that means mod z cannot be 1 greater than 3. Okay, so can mod z take the value 1? No. Mod z cannot be 1. If mod z cannot be 1, no DTFT. Okay, so option number A is wrong. Okay, the DTFT of xn converges if R is such that 2 by 3 less than mod z less than 3. The mod z can take any value between 2 by 3 to 3, and between 2 by 3 to 3, 1 will come, na? 1 is between 2 by 3 to 3, yes. Mod z equal to 1, yes. Okay, if mod z equal to 1 is included in the ROC, DTFT will exist. Okay, DTFT will exist. B answer correct. B answer correct. This is the MCQ question. MCQ only one option correct. If you get the correct option, go ahead to the next question. Okay, I will explain you right now, but in exam, always go ahead to the next question if you are sure about one option. Okay, now what is C option? Anyways, it has to be wrong. DTFT of xn converges if R is such that xn is a left-sided sequence. Okay, now whenever you have a left-sided sequence, ROC is a interior circle. Okay, now inside what? Innermost pole. So what are the poles here? Poles, if I want to write 1 by 5, 2 by 3 and 3. Which of them is the innermost pole? 1 by 5, the smallest pole. So ROC mod z less than 1 by 5. For option number C, they have given in the language form, but if you convert to ROC, mod z less than 1 by 5 is the ROC. And if ROC is mod z less than 1 by 5, okay, why only less than the innermost pole? Because suppose if you take ROC mod z less than 2 by 3, interior of 2 by 3. But if you come interior 2 by 3, 1 by 5 will come. ROC cannot include pole, I clearly told you. But if you go inside 1 by 5, so no other pole will come. That is why inside the innermost pole, okay, the smallest pole. Okay, so will the mod z 1? Mod z less than 1 by 5, mod z cannot be 1. Okay, mod z cannot be 1, no DTFT. Okay, last option. Okay, DTFT of xn converges if R is such that xn is a right-sided sequence. Okay, xn is a right-sided sequence. So ROC is also exterior, going outside. Exterior type of circle. Exterior of what? Exterior of the last pole, outermost pole. Last pole or outermost pole. Okay, or the pole of largest magnitude. Because suppose if you take ROC mod z greater than 1 by 5, if you go outside 1 by 5, 2 by 3 and 3 will come. Pole cannot come. So that is why if you go outside 3, none of the pole will come because there is no pole after 3. Okay, the outermost pole. Okay, so ROC will be mod z greater than 3. Okay, ROC will be mod z greater than 3. Okay, right. And again, if ROC is mod z greater than 3, so if greater than 3 means cannot be equal to 1. This is similar to option A only. That means no DTFT. D also wrong. Anyways, the MCQ question, only one option correct. I told you B is the correct one. Okay. Yeah, correct here. Sai Vikas said B. Shadow also said B. Correct. Vishal, mod z equal to 1 not here. Which one, Vishal? It is there, na? 2 by 3 to 3. Where is 1? 1 is between 2 by 3 to 3, na? 2 by 3 is 0.67. Between 0.67 to 3 only 1 will come, na? Right, Vishal? Just recheck the calculations. So yeah, this is a simple question. Okay, so with this we are done with all 1 mark questions. Okay, we're done with all 1 mark questions of signal and system 2021 to 25, ECE, every single PYQ I have taken, and next session we are going to take all 2 mark question. Okay, I will see, just stay subscribed to the channel and you will get the updates. Next session, all 2 marks PYQs, signal and system, EC plus EE. Again, combining both branch, EC, EE, all 2 mark questions of signals and systems only. Okay, so stay subscribed, you will get the update when I am going to take the next session, but very soon only, within 1-2 days or maximum within the 3 to 4 days. Okay, based on my other schedule. But yeah, that's what all. Maximum within the next 3-4 days, I will take it. Okay. By the time you complete the session, revise the session, I will share you the PDF. Okay, I'll share it by tomorrow. Okay, for control systems, I think I forgot to share, but I'll share for this one also. If possible, I'll share for control also in by Telegram. But for this one, Pakka I will share. Okay, by tomorrow I will share, and I will always, as the rule, keep the PDF as password protected. For those who are dedicated to learn, okay, to understand the questions, they only need the PDF, and my password will be Signal System 1. 1 mark question. SS1, simple. SS1, simple, short and sweet. SNS small. Okay, SS small 1. Okay, SS small 1. Okay, SS small 1. Please note down this password. Okay, yeah, guys. So yes, if you are preparing for GATE 26 and need some guidance, if you have not taken any guidance, so you can still opt for the online live course of OM Institute. Okay, with for GATE 26 1-year validity. Okay, 19,999, and also I did not include here, I forgot, but very recently we have also launched the crash course, the revision crash course for GATE 26. Okay, that's a recorded course. That's not live, but that's a pre-recorded course. Okay, and wherein you can complete the syllabus even faster, or once if you are done with the syllabus, if you want to use it for revision, you can use that for revision as well. Okay, so that's a revision crash course. You can go to our app and you can directly find it. Okay, you can go to, or you just contact our support numbers. They will guide you. 95156 94053. They are going to guide you. Okay, so that for GATE 26 revision crash course is there. For GATE 26 you can opt for this course. Okay, GATE 26, GATE 27 2-year validity course. Online live course priced at 28,999. Okay, that's it, guys. Thank you. We'll bring you the next session on signal and system with all 2-mark PYQs. Okay, thank you. Okay, Vishal, good to know that. Okay, so let's join for the 2-mark sessions. Thank you.